Okay, exponents some more, but in particular, this ever unusual, ever present number 0. Um, Something raised to the 0 power. Why is that always equal to 1? That's supposed to be a number 1. Why is that always equal to 1? Why? So let's just make up a different example. So it is anything raised to the 0 power is equal to 1. Let's just use the letter b and let's raise it to the 4th power, and let's talk about b to the 4th divided by b to the 4th. So first of all, this is the same thing divided by the same thing. Here's another example of the same thing divided by the same thing. And the same thing divided by the same thing is always equal to the number 1. So first of all, it doesn't matter what the exponents are, but the same thing divided by the same thing is always equal to the number 1. However, we just learned that when you divide, you subtract your exponents, and 4 minus 4 is 0. So initially I might have thought of this answer, b to the 4th divided by b to the 4th, as b to the 0 power because I subtract the exponents. But I also know, however, that this divided by this is always equal to 1. So we have another property of exponents. Anything raised to the 0 power is equal to 1. Even a number, 7, raised to the 0 power. So any base. Number 14, even though it's several factors inside the parentheses, it really means 3 to the 0 power times x to the 0 power, because remember, we take these exponents, 3 to the 1st, and we multiply those, and 1 times 0 is 0. X to the 1st, and 1 times 0 is 0. So what you have here is 1 times 1. But this one is 3 times, just the number 3 times. This is called 1. Again, it's 3 times 1. So in this case, that's equal to 3. So be careful. Not everything was raised to the 0 power in this problem, just the x was raised to the 0 power. The coefficient of 3 was truly a factor of 3. All right, the next few problems are going to have some negative coefficients, negative signs in front. Now, they mean, essentially, take a negative 1 and multiply it by w to the negative 5 power. That's exactly what it means. A negative 1 times w to the negative 5 power. So that negative sign in front is understood as the opposite of whatever w to the negative 5 is, or a negative 1 times whatever that is. We know w to the negative 5 is 1 over w to the positive 5. And when you take that numerator and multiply it by a negative 1, you get a negative 1 over w to the 5th. You can put that negative sign anywhere. You can put it in front of the fraction bar, or you could even put it in front of the w to the 5th down here if you'd like. So a negative fraction just has to have a sign either in the numerator or the denominator or in front of the fraction bar. This negative sign right here means a negative 1 times y to the 3rd. But all of that wants to be raised to the 5th power. So a negative 1 to the 5th power means a negative 1 times a negative 1 times a negative 1 times a negative 1 times a negative 1. Well, that's an odd number of times. You know, 1 times itself 5 times is just 1. But when you multiply a negative 1 an odd number of times, you get a negative 1. This y to the 3rd gets raised to the 5th power, and the property is to multiply 3 times 5. So we have a negative 1 times y to the 15th, and many people would just write that as a negative y to the 15th. They wouldn't bother with that 1 in front. All right, let's keep going. I believe the negative signs continue. Number 18 is a little bit more challenging yet. I'm going to suggest that with number 18 that you see this negative 4 right here? All of this is raised to the negative 4 power. I think it would be easiest for us to see if we rewrote what's in the parentheses here as 1 over what's in here to the positive 4th power. So change that. And we would then have downstairs a negative c to the 4th. You can't drop that negative sign. It's the opposite of c to the 4th. You just are not allowed to drop that. This sign right here has got to come down. So now I'm going to raise all of this to the 4th power. So 1 to the 4th is just 1. And actually I'm going to bring this sign along first. So I'm bring that down. 1 to the 4th is 1, and this is a negative 1 raised to the 4th power. That's going to be a positive 1. C to the 4th raised to the 4th is c to the 16th because I multiply. Again, a negative 1 an even number of times is positive. So I have 1 over a positive c to the 16th. However, this sign that was out in front, it's this sign right here, ends up making this as the opposite of 1 over c to the 16th. So there's my final answer. Okay, let's start to put it all together. In number 19 in the numerator, let's multiply where the bases are alike. So we add their exponents, so we get y to the 8th. I hope every once in a while you pause the video so you can do these on your own. And then here, raising a power to a power, you multiply those exponents, so you get a 15. I'm wondering if you'd be okay in this problem with noticing there's 8 y's upstairs. There's 15 y's downstairs. So I'm going to think about subtracting from here to here. So 15 minus 8 is 7. But it means there are 7 y's left downstairs with a 1 upstairs. The other way to do it, though, is to take 8 and subtract 15, and you'll get a negative 7. But then your answer would have been y to the negative 7. And you have to rewrite that with a positive exponent as 1 over y to the positive 7. So it's faster to just go ahead and look at that when they're both positive and say, oh, I'm going to have more y's downstairs, and it's going to be the difference. Gets a little bit more challenging when I have all these negative exponents. Let's do these last two. So number 20, one way to do this is to raise all of this to the negative 2 power. That's one way. And the other way is to write this as its reciprocal raised to the positive 2 power. That would probably throw us a little bit. So, and I may do it both ways. We'll see. I'm going to raise it all to the negative 2 power. So this 3 gets raised to the negative 2. Remember, when you raise a power to a power, you multiply the exponent. So a negative 3 times a negative 2 is a positive 6. That's kind of cool. But 4 times a negative 2 is a negative 8. And so now this factor and this factor right here have to be put downstairs. They have to be thought of as 1 over 3 squared, which is 1 over 9. Leave the m to the 6th where it is. And this has to be 1 over n to the 8th. So finally, my answer to this problem is the m to the 6th stays upstairs. It doesn't need a 1 with it. The 3 squared is 9, and I have n to the 8th downstairs. There's just so many approaches. We're done with that problem. That's all done. But you could even take this problem and write what's in the parentheses as 3 n to the 4th over m to the 3rd. Do you see how I moved just this m to the negative 3rd downstairs, and now that's raised to the negative 2 power. Next, I want you to know that there's a property. If you have a fractional expression raised to a negative power, you're allowed to rewrite it as the reciprocal of that fraction, m to the 3rd upstairs, 3 n to the 4th downstairs. But when you do that, when you flip that, this becomes a positive 2. That's like thinking of this whole thing as 1 over this fraction to the positive 2 power. And then would you notice that m to the 3rd squared is m to the 6th, 3 squared is 9, and n to the 4th raised to the 2nd power is n to the 8th. Therefore, I'd like to use that property in this problem. I'd like to put y to the 7th upstairs and 2b to the 4th downstairs. And now I get to raise all that to the positive 3 power. That gets rid of my negative exponent right away. And so 7 times 3 is 21. So I'll have, let's see here. So I have y to the 21st power, and then 2 to the 3rd power. I'm going to write that off here. 2 to the 3rd power means 2 times 2 times 2. That's 8. And b to the 4th raised to the 3rd is b to the 12th power. The next segment will be on order of operations with exponents.